Hello nerds, welcome to my YouTube channel and my name is Veron Sofa. Today we are going to talk about partial fractions. But before we go further, please don't forget to like my videos and also subscribe to my YouTube channels so that every time I post a video, you'll get notified. So our main focus today is partial fractions. So what are partial fractions? Okay, so let's see what partial fractions are. So we've got a rational expression here. This is a rational expression, or in other words, this is a fraction. So when you decompose a fraction into its simpler parts, those parts are called partial fractions. So we can see this here. This is the rational expression 3x plus 5 over 2x squared minus 5x minus 3 is equal to 2 over x minus 3 minus 1 over 2x plus 3. So this 2 over x minus 3, it is a partial fraction. The other partial fraction, it is negative 1 over 2x plus 1. So what does it mean? This means that when you decompose this fraction that we have here, you are going to end up with these two fractions. So when you decompose a rational expression or a rational fraction, what you are going to get are partial fractions. So decomposing simply means when you break it down into its simplest fractions, you're going to end up with partial fractions. So when you add these partial fractions, you're going to get this. So as simple as that. So don't be scared about the partial fractions. It's not something to scare you. It's a very simple mathematical topic here. So just know how to decompose this into partial fractions, and you are well and good. So in this video, I'm going to teach you how to decompose rational fractions, into partial fractions. Okay. So here again, we've got an example. So representing a partial fraction, we've got an example. This is a normal fraction, or in other words, a rational fraction. That rational fraction, when it is decomposed or when it is broken into simpler parts or into simpler fractions, are going to end up with these two fractions. So these two fractions are called partial fractions. All right, nerds, let's see how we can now convert those, how we can break down a rational expression into partial fractions. So for you to do that, you need to know certain rules that are involved. What are those rules? Let us look at this amazing table. So actually, there are 4 rules. So these basic rules, they can help you to solve almost any question on partial fractions. So the first rule, we have got nx over ax plus b times cx plus d. So imagine that n is any numerical value. It's a coefficient of x. So n coefficient can be any number here. 6x. So imagine that this is a number, and then this is a variable. And also imagine that here a is a number, b is a number, c is a number, d is a number. So here we've got, this is the factorized form of an equation. So here we have got 2 factorized form of equations, and then there I've got a variable as well. So these are called linear factors. Okay, so whenever you have got things like this, we're going to look at examples, don't worry about that. So whenever I've got things like expressed in this form, okay, so how can we, or how can you break down this into its partial fractions? So what we do when you've got linear factors, what we do is that this is the formula that you're supposed to use. You say a, so a is just representing any value or any answer that you are going to find divided by ax plus b. Where is this coming from? This is coming from here. So ax plus b. Then plus b over cx plus d. Okay. So we're going to look at the example. Let us look at the example here. So let's say that you've got 6x over 4x plus 3 and then times x plus 2. Okay, so according to this formula, what should you do? When you look at this formula, on top you put a. So if you want to decompose this rational fraction into its partial fractions, what you do is that on top there you put a, then divided by, what's the first thing? Ax plus b. In this case, it is 4x plus 3. Okay, and then plus b over what? Over this, which is x plus 2. When you do that, what do? We are going to learn how to solve those questions. I'm just showing you how to break down a rational fraction which has got linear factors into partial fractions. Sorry. So how can you decompose that one which has got linear factors? So linear factors, it means these here, these factors down here, denominators, these factors, they are linear. What does it mean? Whenever you hear that something is linear or it's a linear equation, it means when you plot it on the graph, it's going to give you a line. Okay? So these two equations or these two factors, when you plot them, they should give you a line on the graph. Or in other words, all equations that have got the highest power, which is 1, they're called linear. For example, you see here, the power of this x, it is power 1, x to the power 1. That's why we're calling it linear. For example, if it was plus 3, this is quadratic. Okay? If the power is 2, it is quadratic. If the power is 3, it is cubic. So this is a quadratic equation or quadratic factor, and this is a cubic factor because of this 3 here, this power 3. This is a quadratic because of this 2, but this one, it has a 1 on top there. That's why we are saying it is a linear. So when you graph it, it will give you a line. Okay, so these are linear factors. So whenever I've got these linear factors or factors whose highest power is 1, you do this, what you have done here. You say a over this factor plus b over this factor. That's what it means. And then the other things to do, the next things to do, I'm going to teach you, I'm going to give you an example on that. All right. So let us look at the second part as well. So let's look at the second part. So the second case is where I've got repeated linear factors. Okay, where the denominator is repeating itself, or in other words, the factors of the denominator are just being repeated. Okay, so here I've got this is a number, or this is a coefficient x, this x is a variable, and then over this factor here, but times 2. So it means ax plus b squared, which means ax plus b times ax plus b. That's what it means, okay? Yeah, so ax plus b squared, it simply means ax plus b times ax plus b. As simple as that. So now, how can you break down this type of equation or this type of fraction into partial fractions? So what you're going to do simply, you say a over ax plus b to the power 1, or in other words, just a over ax plus b is the same thing, plus b over ax plus 2. These two. Okay. So I'm simply saying this. Let's say I've got 6x divided by, let's say, 2x plus 3 squared. And then we are told to break down this rational expression into its partial fractions. So what do? What we are going to do is simply say a over, we start with 2x in the brackets plus 3, then plus b over the whole thing, which is 2x plus 3 squared, like that. Now imagine if we had 3 here, the power was 3. If the power was 3, we would have added another thing here, would have said plus c over 2x plus 3 to the power 3. So if the power was 4, we would have continued in that manner. That's the way it goes. So whenever we've got repeating factors, okay, because why I'm saying these are repeating factors, the reason I'm saying that these are repeating factors is because 2x plus 3 squared is the same as what? Is the same as 2x plus 3 times 2x plus 3. Okay, so 2x plus 3 times 2x plus 3 is the same as 2x plus 3 squared. That's why we are saying these are repeating factors, because they are repeating. Okay, 2x plus 3, and then here 2x plus 3. In the first example, we are different factors, okay? But they were both linear factors. But in this case, these two are linear factors, and then the same. They are the same. They are repeating. That's why we are saying that for repeating linear factors, what do? We use this method. All right. I hope that is simple and clear. In case of a question, please don't forget to send an email or text me on WhatsApp. Okay. What if you have got something like this? Let's say you have got a linear and repeated linear factors. Okay. So we have got this is a linear. The first one, it's a linear factor. The highest power is 1 on x. And then here we've got this one, it's repeating. This one is not repeating, remember? Ax plus b. Then this one, cx plus d, is repeating 2 times. How can you do it? So the first is a over ax plus b, then plus b over cx plus d, plus c over cx plus d. So what you're simply doing here is that this part is just a combination of the first and the second. Okay, so if you just combine this and this, we are getting this thing we're talking about here, the linear and the repeated linear factors. So it's very simple, right? It's very simple. So the first thing that you say a over the first factor, which is not repeating. This first factor is ax plus b. Then plus the repeating factor, which is cx plus d squared. So what do? You say b over cx plus d, and then plus c over the same repeating factor, but square it. Get it like the way it is there. You put it like that. All right, needs. We are going to look at examples. Don't worry about that. So now, let's do now the final one. The final one is where now we have got a quadratic key factor. So what is a quadratic factor? It means it cannot be factorized. It cannot be simplified or factorized further. So that one become a bit tricky. How do we do it? But things are so simple and straightforward, Ninja needs. So what we are going to do is that this is, have you seen here? This one is a linear factor, but this one is not a quadratic. Remember, because I said linear factors are factors which have got the highest power of 1. Quadratic, they have got the highest power of what? Of 2, or the degree is 2 for quadratic. Yeah, so for quadratic equations, have you seen quadratic factors? The x variable has got a power of 2. Here, the x variable has power of 1. That's why we're calling it a linear. Because when you graph it to give you a line, but quadratic they've got a power of 2, and when you graph it, it's not going to give you a line. All right. So whenever you've got a rational expression or a rational function, or in other words, sorry, or a rational fraction, I mean, whenever I've got a rational fraction, and that rational fraction, when you look at the denominators, you find that the denominators, they have got a quadratic equation or a quadratic factor which can't be factorized. What should you do? You have to do like this: bx plus c over x squared plus c squared. All right, so if there is a linear, so this is the part of the linear, you say a over the linear part, but plus, if this is the quadratic, you say bx plus c over x squared plus c squared. All right, let's just look at examples. What I'm talking about here. So let's say I've got 6x divided by 2x squared plus 4. Okay, can you factorize this? You can't, right? All right, if you find that you can't or you can, okay, let's just say plus 6. It's going to be hard for us to factorize. So what are we going to do? We're just going to say, what are we going to do? We're going to say ax plus b over 2x squared plus 6, like that. So if you can't factorize it, just say ax plus b and divided by this whole thing. Take it as a factor like that. So take the quadratic factor just like that and put it down here. Okay. So in a case whereby we have got a linear factor here, let's say you have got, like in this case, if you have got a linear factor like that, so you should start with a over the linear factor, then plus bx plus c. But in this case, don't have a linear factor here. There is no linear factor here. That's why we didn't. That's why a is having x, then plus b. But in this case, there was a linear factor. So sometimes we can be given a linear factor there and a quadratic factor as well. Sometimes there can be just a quadratic factor like that. So don't have to master, you have to know these things. All right, Neds, let's go and look at some examples. So we've got this example, okay? So this example that we have here, it is saying x plus 4 divided by x squared minus x minus 2. So the first thing that you have to do is to factor the denominator and see if it is giving you linear factors, quadratic factors, or repeated factors. So that's the first thing. So we are going to factorize this denominator. Okay. How do we factorize the denominator? All right, let me show you. So the denominator that we have there, I've got x squared minus x minus 2. So how do we factorize that? We need to find the product, sum, and the factor. So what's the product? The product, you multiply this and that. Okay, the first value and the last value, or the first variable and the last variable. So you get negative 2 times x squared, you get negative 2x squared. The sum is the middle part, okay? So the sum in this case is negative x, or in other words, you can say negative 1x. Negative 1x. What are the factors? Two numbers that when you multiply, they give you negative 2x squared. And when you add them, they are going to give you what? Negative 1. Okay, so those numbers, you can say it is negative 2x squared and positive 1x. Okay, all right, sorry. So just should be, sorry about that. Just say negative 2x and positive 1x, like that. Not negative 2x squared, but negative 2x and positive 1x. All right. Our aim is to factorize the denominator. And once we factorize the denominator, we're trying to see if it is giving us a linear factor, quadratic factor, or a repeated factor in the denominator part. That's why I'm trying to factorize this. So this is the denominator. So I want to factorize it. So let us see. So we are going to write it as x squared minus 2x plus x. So minus 2x plus x, then minus 2. These two come here. So we're going to do that, pair them, put them like that. So here, what's the common factor? The common factor is x here. So we take out x, and then we are going to remain with x there and the minus 2. What about there? What's the common factor there? Just 1, right? Yeah. No other factor apart from 1. So we're just going to say positive 1 x minus 2. Whenever you have got these things here inside the brackets the same, just so that you are in the right direction. So just get x and the 1. You say x plus 1 times x minus 2. So they are factorized like that. That's how we factorize it. So look at that. X plus 1, x minus 2. X minus 2, x plus 1. It's the same thing. So that's how we factorize that. Okay, so when you factorize that, what should you do next now? So what you should do now, we've seen that this now is a linear, these are linear factors. So we are going to use the first law. What's the first law stating? This is the first law. If you've got linear factors, your formula is that one. Pretty simple, right? So that's the formula. because what we have are linear factors. So let's see now how we are going to solve that one. So the formula, we've broken this one, or we factorize this one into x minus 2 and x plus 1, like that, which means these are linear factors. So the formula for linear factors will say a over what? Over the first factor x minus 2 plus b. A and b, these are unknown values. We're trying to look for a and b, so don't be confused. We're trying to find a and b. Okay, we know the denominators. It's x minus 2 and x plus 1. X minus 2 and x plus 1, but we don't know the values of a and b. So we're trying to look for a and b. So a over x minus 2, which is the first factor, plus b over x plus 1, which is the second factor. What do we do from there? Let me show you what we do from there. So just rub here quickly so that I show you how to do that part. Okay, so actually talking about we've got x plus 4 over x minus 2 x plus 1. Okay, so according to the formula, what do? We're saying that you say a over the first factor x minus 2 and then plus b over the second factor x plus 1. So what do we do next? We need to multiply everything by what? By these two factors. So multiply everything in the brackets by these two factors. So you can say that this is x minus 2 x plus 1, like that. Alright, Ninja Needs. So from there, what do? You multiply x minus 2 times x plus 1 times this here, x plus 4 over x minus 2 times x plus 1. So you find that something will cancel here. What's going to cancel? This and that will cancel when you multiply that. Alright, so here you remain. So when you multiply this times this here on the left side of the equal sign, only this part, you're going to remain with x plus 4, because this and this will cancel. Alright, but what if you multiply this thing with this part, a over x minus 2 only? What are you going to get? You're going to find that x minus 2 will divide, will remain with x plus 1 and a. So is equal to a, open brackets, x plus 1, right? So what I'm simply doing is that this is not completely being divided by that. It's not, I mean, when I divide this into that, it doesn't mean that this is going to disappear. No. So this, I divide it to that, would remain with x plus 4. But again, the same things, these to x minus 2 x minus 2 times x plus 1. Again, I'm going to multiply it with a over x minus 2. So that I cancel x minus 2 and x minus 2, I'll remain with x plus 1 and the a here. A times x plus 1, I'm going to have a times, or a open brackets, x plus 1 close brackets. The same thing is going to happen at b. So b over x plus 1 times x minus 2 times x plus 1. So x plus 1 and x plus 1 will divide. I'm going to remain with x minus 2 times b. You understand that, right? So that's very simple. So there's a plus here, so I'm going to have a plus b x minus 2. Okay. So actually when you do that, so here there are many methods that we can use. There is what we call distributive method, so we can distribute actually. So what do you mean? We're going to say we can distribute x plus 4 is equal to, we can distribute, multiply a times x and a times 1. So a times x, we are going to have ax. A times 1, we are going to have a. Then plus b times x, bx. B times negative 2, negative 2b. Like that. Okay, then we are going to correct like terms. What do we mean? Those with x, we put them together. And those without x, we put them together. So here ax plus bx. These two, they have got x. So we put them together. what are we going to have? We're going to say x plus 4 is equal to ax plus bx plus a minus 2b. All right. When we do that, what are we going to do? We are going to factorize x in this case. So these two, both they have got x. So we can factorize x as a common factor, right? Can take x outside and put them in the brackets, a and b. All right, so let's see how we're going to do that. So say x plus 4 is equal to a plus b, and then we take out this x outside. So we put it outside here. And then these will just be the same. Or we can put them out in the brackets as well if we want, but it doesn't matter. Okay, we put them like that. So now we're going to compare what we have on the left-hand side and on the right-hand side. So those that have got a hex, we compare with them with the x on the other side. All right, so this x, we compare with this having x. This 4, which doesn't have x, we compare with that without x. In other words, we equate them. So what you're going to do that, we're going to equate this to this. So we say a plus b x is equal to x. Which x? This x. So a plus bx is equal to this x, because this, they have got x and here there is x. So that's how we do it. So here you put everything that is having x, everything that is having x, you put them together and then factorize x, then you compare or equate them to the value or to the thing that are having x on the other side. So this equal to this. Okay, so here we can divide by x by x. What are we going to remain with? So when you divide by x, x and x will cancel. So we are going to remain with a plus b. X divided by x here, it's 1. So it's equal to 1. So this is our first equation. This one is our first equation. Note it. What's the second equation? We said we remained with something that doesn't have x. A minus 2b is equal to 4. That one we equate it as well. That one will say a minus 2b is equal to 4. So this is our second equation. So now what do? We solve this equation simultaneously. If you want, you can use substitution method. Just depends with what you want. If you want, you can use the graph method. Just depends here. So I've got two equations. We can use simultaneous equation method, or in other words, you can use substitution method or elimination method in other words. Okay. So we can use all those methods of simultaneous equations. Okay. Substitution method, graph method, or elimination method. So in my case, I'm going to substitution method because it's the simplest. All right. So what I'm going to do, I'm going to make one thing here as a subject to the formula. So I'm going to make a subject to the formula. So what am I going to do? I'm going to say a, I'll take b to the other side. So a is equal to 1 minus b. When I do that, what am I going to do next? I'm going to replace where this a there in that second equation with 1 minus b. So I'll say 1 minus b, I put it there. Replace a with 1 minus b, is then minus 2b is equal to 4. All right, so 1 minus b minus 2b is equal to 4. Negative b minus 2b is equal to what? Negative 3b. Okay, so here we're going to have 1 minus 3b is equal to 4. What else? 1 minus 3b is equal to 4. Correct right terms. So 1 will come to this side. What are we going to have? Negative 3b is equal to 4 minus 1. So negative 3b is equal to what? 4 minus 1 is 3. So divided by negative 3, we find that b is equal to actually negative 1. So that's how we find that. So our b is negative 1. Having found b, let's find a. We are going to use this equation there. A is equal to 1 minus b. What is b? Negative 1. Simple, right? So just say a is equal to 1 minus b. 1 minus what is b? negative 1. So a is equal to 1 plus 1, because negative times negative is positive. 1 plus 1, which is giving us what? Giving us a 2. So actually a is equal to 2. That's the second answer. So when you look here, this is what they found as well. So b is negative 1 and a is equal to 2. Alright, so when you find that now, you get back to your what? You get back to your formula that you are using to calculate this question. What formula was that? So if you remember, we said for linear, this is the formula that we used. Because since the denominators are linear, or the factors are linear, so we used a over x minus 2 plus b over x plus 1. So what is our a? Our a, we have seen it is 2. So you put there 2 x minus 2 plus, sorry, yeah, okay, you can put plus. Then what is b? Negative 1 brackets over x plus 1. What's going to happen here? So it's 2 over x minus 2. And then we know that this is positive, negative. You're going to have a negative actually. So negative 1 over x plus 1. So when you do this now, it means you are done with your question. So this here, these two, this one and this one, these are partial fractions. So partial fractions of which fraction? Of this rational fraction, this one. Okay, so when you break down this one, you are going to get these two partial fractions, 2 over x minus 2 minus 1 over x plus 2. So these two partial fractions. So that is how we do. That is how we solve these questions. Okay, so when you reach this level, it means you are done. As simple as that. All right, I hope that is understood. Let's see another example. So this question leads